This example is what you're going to be doing for linear programming with constraints and the objective function given. So this is the portion where if you do this, you can meet the expectations of the standard, and you are given the constraints and objective functions, so you don't have to find them. So you are actually starting out with number 2 of the 3 pieces of finding linear programming, the answer. With feasibility and boundaries, you're going to be graphing the constraints and identifying the critical points. And to show your work, you're going to graph using Desmus and then take a screenshot and insert it. And then portion 3 is the solution. You're going to be identifying the mathematical solution using the critical points, writing the solution to the question asked in the word problem. So on our rubric you'll be graded on, we're going to look at the exemplary because that's what we're shooting for. Is clearly defines the feasible region by identifying all of the critical points correctly. So that's with the feasibility and boundaries. And then with the solution, exemplary provides a clear and correct interpretation of the optimal solution, including the values of the variables and the objectives of the function. So this is the problem that we are given to work on. The area of a parking lot is 600 square meters. A car requires 6 square meters. A bus requires 30 square meters. The attendant can handle only 60 vehicles. If a car is charged $2.50 and a bus is charged $7.50, how many of each should be accepted to maximize income? The area of a parking lot is 600 square meters. That's in pink because it's filled into the table. But this is given. You're not going to usually see the colored version of it. You'll be seeing the constraints given. But I'm going to give you the table so that you can follow along as to how they fill out the table and then write the constraints so that you can work towards exceeds expectations. So the constraints here are x is greater than or equal to 0 and y is greater than or equal to 0. 6x plus 30y is less than or equal to 600 meters squared, and x plus y is less than or equal to 60. So we want to take the constraints in the first part and we want to put them into the graphing or the Desmus calculator. The objective function is to maximize $2.50 times x plus $7.50 times y, and that will give us our final solution answer. Okay, so I'm going to graph the constraints and identify the critical points. That's the feasibility and boundaries, graphing the constraints and identify the critical points. To show my work, graphing using Desmus and taking a screenshot and inserting it. So I'm going to graph on Desmus only the constraints, only the inequalities. Take a screenshot of the inequalities entered and another screenshot of the feasible region with the critical points identified. So this was my screenshot. This is the constraints. This is my feasible region, and my critical points have been identified. So then I'm going to take those critical points and I'm going to be plugging the values for the x and the y into my objective function. And I'm going to look for the maximum. So my objective function was given to me, so I just copied it down on this sheet. These are my critical points that I got from my graph, and I plug them in, and I find out my answer, and then I'm looking for the maximum, so my largest number in my answers is the 200. So when I'm answering the question, how many of each should be accepted to maximize income, that's how many cars and how many buses, the maximum income is $200. This is obtained by allowing 50 cars and 10 buses to park because I got 50 and my x was the variable 50 and my y is the variable for 10. Okay, and 50 is the cars and 10 is the buses. So that's how 50 cars and 10 buses to park. Okay. So we're going to give you some problems to try it out before the mastery check, where we'll do another problem before that also.